Solar is one of the most reliable sources. It does not create pollution, is not radioactive, and its source is free, but the systems themselves are still relatively expensive. It's estimated that if the sunlight that hits the Earth in one day was collected, it would power the Earth for 50 years. Solar radiation is categorized in four forms: natural daylight, thermal energy, which is energy caused by warmth; photosynthesis, which is how plants use sunlight to make their food; and photovoltaic, which converts electromagnetic radiation from sunlight into electricity. A fifth form could be wind power, since heat of the sun creates wind. Passive solar heat uses the sun to heat a building using walls, ceilings, and floors to collect, store, and radiate energy in the form of heat. There are three different passive solar heating types. They are direct gain, indirect gain, and isolated gain. Active solar heat uses the sun to heat a building using air and liquid heat. The sun heats the air or liquid and stores the heat in an interior storage system. An example of an active solar heat system is a solar swimming pool heater. Shade can lessen the amount of hours cooling devices need to run and can even make the devices unnecessary. Trees not only create shade, but cool themselves by pulling water from the ground to their leaves, which evaporates and cools the surrounding air. Romans developed the first central heating system in the 1st century. This system used hot steam from a wood or coal fire in the basement, an area called the hypocaust, and distributed the warm air through the home through terracotta tubes. In the 11th century castles, about 80% of heat went up the chimney. In 11th century castles, large clay and brick walls behind the fireplace were used to absorb heat to be radiated into the space later on. The Industrial Revolution brought steam heat to Europe, and in 1880 it popularized in America. Unfortunately, at this time, solar energy only supplies about 2% of U.S. energy and 0.1% of Canadian energy. At this point in time, fossil fuels are more widely used. This includes gas, oil, and coal. These fuels create CO2, sulfur dioxide, and nitrogen oxides, and nitrogen. Radiant heating systems are becoming more popular as technology expands. You can have radiant floor heating, heated ceilings, heated gypsum wallboard, and even heated towel racks in your washroom attached to your home's heating system. The three main types of furnaces are forced air gas furnaces, which are the most widely used because it is inexpensive to operate and does not require storage. The oil-fired furnace requires on-site storage. Electrical forced air furnaces have no combustion and are very efficient, but expensive to run due to high electricity costs, expensive to fuel due to high efficiency, but expensive.
Cooling systems such as air conditioning units are what makes scorching hot summers a little more bearable. In a country like the U.S., where climate zones vary, 2/3 of all homes use air conditioners. To use, however, costs $11 billion annually, makes up 5% of all energy used, and adds 100 million tons of CO2 into the atmosphere. Building design has been affected by the incorporation of air conditioning and electric lighting. Windows are no longer needed for ventilation in daylight, therefore reducing the amount of windows installed in rooms as well as lowering the ceiling heights. Air conditioning treats the air, maintaining appropriate temperature, humidity, cleanliness, quality, and motion. Design techniques such as southern exposure shading with horizontal overhangs, covered awnings, plants, and other shade devices will help reduce cooling loads. The use of natural ventilation opposed to mechanical conserves energy, lowers utility costs, and allows for better life balance. Natural ventilation is the movement of warm air up and cooler air down through convection. Cross ventilation uses wind flow through a building. This type of ventilation is best for narrow, open-plan buildings with well-placed windows and doors. Stack ventilation draws cool air into the space from lower down to replace warmer air that naturally rises as it's warmed. Stack ventilation is generally a weaker option than cross ventilation. Cooling techniques such as pre-cooling can assist mechanical cooling systems, reducing the system's cooling load prior to occupancy. Pre-cooling lowers the heat amount released within the room during peak hours. With its occupancy patterns, churches and theaters best suit the use of pre-cooling. Fans can help to cool small buildings. Air motion differs depending on the fan's height above the floor, its power, speed, blade size, and quantity within the space. Effective fans to install are ceiling fans, attic fans, window fans, and whole house fans. Mechanical air conditioners suck warm indoor air through coils containing refrigerants, then blows it back into the room. The heat is absorbed by the refrigerant in the evaporator, then exhausts it outside through more coils and fans in the condenser. As indoor air cools, it also dehumidifies. Moisture removed from the air condenses on the cool coils. Water runs down a drain or drips off the air conditioner outside. HVAC systems integrate both heating and cooling into one system. HVAC systems use air, water, or both to distribute heating and cooling energy. Most systems use furnaces, which supply hot air, and boilers that heat water or produce steam. System selections are made by a mechanical engineer based on performance, efficiency, and initial life costs of the system. HVAC equipment can take up between 10 and 15% of the building area. Depending on climate, heating and cooling needs and concerns will be addressed with the selection of either centralized or localized equipment by the mechanical engineer. Localized equipment is best effective in buildings where heating and cooling needs vary from room to room. The basic tasks of an HVAC system include heating, cooling, and ventilation. Thermostats control the flow of water to radiators and convectors. Fans that circulate warm air also use thermostats. A thermostat triggers a low-limit switch, which turns fans and pumps on for the heat distribution system when a preset low temperature is reached. An upper limit switches off the furnace when specified temperature is reached.